So today we're just going to do the Target 12 part of this homework, so just numbers 1 through 4. So remember, we're graphing our piecewise functions, and I'm going to use tables to help us. So we don't have a whole lot of room, so I'm going to squeeze the tables over here on the left-hand side. So we have x squared minus 4 when x is less than negative 2. So here's our xy chart. We start at the x value of negative 2, that's what's in the inequality. This is x is less than negative 2, so I'm going to pick negative 3 and negative 4 as well. We're going to plug these into our calculator, or maybe just into your brain. That should be a negative 4. Oops. And we're going to see what we get out. So if we plug in a negative 2, that would be 4 minus 4, which is 0. If you plug in a negative 3, that would be 9 minus 4, which is 5. If you plug in a negative 4, that would be 16 minus 4, which is 12. Before we graph this, think about if your first point should be open or closed, and it should be open. If you weren't getting those values, when you plug into this equation, make sure you do parentheses in your calculator. If you don't, then it'll give you the wrong value. So starting at negative 2, 0, we have an open point. Then we have negative 3, 5, 1, 2, 3, 4, 5. And then we go off the graph. So it's, remember, this is a quadratic, so it kind of has a U shape to it. That wasn't great, but you can kind of tell there's a U shape there. And then we have our second table that we're going to create, which is for 2x plus 3 when x is greater than or equal to negative 2. So again, starting our table at the x value of negative 2, since that's what's in the inequality. X is greater than or equal to negative 2, so picking some values that are greater than negative 2. And then I'm going to plug these into our equation, so that would give me a negative 1 if I plug in a negative 2. Then that would give me a positive 1 and a positive 3. That first point is going to be closed because there is an equal to part to this inequality. So at negative 2, negative 1, we have a closed point. Then we have negative 1, 1. And then we have 0, 3. It starts at the first point and goes through the next two. So let's look at some of the questions it asks us about this graph. So first of all, is it a function, yes or no? Remember, these are called piecewise functions, so the answer should always be yes. Does it pass the vertical line? Yes, our graph does, but it's always a good thing to check. F of 3. So f of 3 means that we're plugging in 3 to our equation. And so let's look up here. Where would we plug in 3? Remember, look at your inequalities. Where does 3 fall? 3 falls into the bottom category. 3 is greater than or equal to negative 2. So if I plug in a 3, this is just review, guys. So if I plug in a 3, I get out 9. Negative 4 would fall under this category. It's less than negative 2. And if I plug that in, I get out a 12. And notice, we could have also looked at our table for that. Negative 4 was 12. And so then at negative 2, another way to evaluate this would be from the graph. Look at the x value of negative 2. It's right here. Remember, you always pick the closed-in point, so the output would be negative 1. So you can either evaluate from the equation, from the table, or from the graph, and I usually do a combination of those. Moving on to number 2. So again, we're going to create two tables, starting with our first one. We have absolute value here. So I'm going to start my table at the x value of 1, and it says x is greater than or equal to 1, so I'm going to pick 2 and 3 as well. If I plug in a 1, that would be 5. If I plug in a 2, that would be 3. And if I plug in a 3, that would be 1. And that first point would be closed since it is equal to. So let's go ahead and graph this. So 1, 5. then we have 2, 3, and then we have 3, 1. And I'm actually going to plug in one more number because if you notice, if I plug in a 4, so just continuing that pattern, I would get a 3 out. So you can really see the absolute value here. So I only picked 3 points to start with, but you might want to pick more if you want to think about what the graph could look like. So it starts at this first point, and then we have our absolute value, and it'll continue in that direction, but make sure you only have one arrow there, just to the right. And then our second table is going to be for that second equation, which is 3, x is less than 1. So our table again is going to start at the x value of 1. Its x is less than 1, so let's pick 0 and negative 1. If I plug those into the equation, this is one of those, it's almost tricky, but you always get 3 out. And this is going to be an open point to start with since there's no equal to our inequality. So 1, 3 is going to be an open point. And then we have 0, 3, negative 1, 3. It starts at the first point and goes through the next few. And this is just a horizontal line. If you ask yourself, is this a function? The answer should be yes. It passes the vertical line test. And then we have some evaluations to do. So at negative 2, if I look at the graph, at the x value of negative 2, the output is right here. And that output would be a 3. You could also plug it in to figure that out. If we were trying to figure out where's f of 6, and again I can use these inequalities to help me, 6 would fall into this category. 6 is greater than or equal to 1. If I plug in a 6, that would give me 7 out. And then if we did f of 1, we can look at the graph again. Here's the x value of 1. Choose the closed point, and if you remember, that was at 5. So those are just some review going back to one of our first targets, I think target 2. All right, so number 3, we have a quadratic and an absolute value function. So we're going to create our two tables. It doesn't matter what it is. We always treat it the same with our tables. Oops, lost my x. So I'm going to start with the x value of 2. And this is x is less than or equal to 2, so let's pick some numbers that are less than or equal to 2. Like 1, 0, and negative 1. So I'm going to plug those in, and you can use your calculator to help you as well. So that would be 9, half of that's 4.5, 5.5 I think is what I get out. And if I plug in a 1, 2 squared is 4, half of that is 2, that would be a 3. If I plug in a 0, that would be a 1.5. If I plug in a negative 1, that would give me just 1. If I plug in I wonder what happens if I plug in a negative 2. If I plug in a negative 2, I believe I get out a 1.5 again. So the reason I was looking for that was this is a quadratic, so I was looking for that bounce back in the table so that I could include that. That first point is going to be a closed point since there is an equal to, so let's go ahead and graph this. 2 is at 5.5, 3, 4, 5, lost count, 1, 2, 3, 4, 5. Okay. And then we have 1, 3. And we have 0, 1.5. Then we have negative 1, 1. And then we have 2, 1.5. So again, you can see that graph have that bounce back, but notice I'm only continuing this graph in that one direction, going towards the left, not the right. And then for our second table, we're looking at that absolute value. Oops. So our table is going to start at the x value of 2. it says x is greater than 2, so let's plug in some numbers that are bigger than 2, like 3, 4, 5. If I plug in a 2, that will give me negative 4, 4, half of that's 2. If I plug in a 3, that would give me 1.5. If I plug in a 4, that would give me 1. If I plug in a 5, that would give me, that would be negative 1. That would be half, so 0.5. And you can also use your graphing skills to help you, so I'll show you what I mean by that. So we have 2, 2, and remember that should be an open point. And then we have 3, 1.5. We have 4, 1. 5, 0.5. And so what I was saying is you could use your graphing skills. So just think about what this absolute value function graph looks like. The vertex is at 6, 0 with a slope of 1/2. So I can go ahead and predict that those points are going to start bouncing back. And then we have some questions to consider. So is this a function? Does it pass the vertical line test? Yes, it does. And the x value is negative 4. What's the y value? So use your inequalities to help you if you'd like. Negative 4 would fall under this first category. If I plug in a negative 4, that would give me 5.5. For 8, that would fall under this category. If I plug in an 8, that would give me a 1. And 2 would fall under this top category again, or you could just look at the graph. Remember that y value was at 2.5, or sorry, 5.5. And then your last one from your Target 12 homework, it has 3 parts. I'm going to try to make the tables down here at the bottom, or maybe a combination, just kind of curve them around. So starting with x plus 1 squared minus 2 when x is less than or equal to 0. So we're going to start this table at 0. And it says less than or equal to 0, so let's do negative 1, negative 2. If I plug in a 0, that gives me out a negative 1. If I plug in a 1, that gives me out a negative 2. If I plug in a negative 2, that gives me out a negative 1. So plotting these points, starting with a closed first point, 0, negative 1. And then we have negative 1, negative 2. And then we can see that quadratic starting to form. So starting at the first point, going through the next 2. I'm going to go ahead and flip to that last part, so where it says 3, x is greater than 5, I will come back to that middle part. So the number in this inequality is 5. It says x is greater than 5, so like 6 or 7. This is one of those where there's no value to plug in, so we're just going to use the value of 3. And notice that this should start with a open point since there's no equal to. So at 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. That's an open point, and then 6, 3, and 7, 3, and so it's just a horizontal line. Starts at the first point, goes through the next couple. So now we have that middle part, 2x minus 3, and 0 is less than x, less than or equal to 5. So on this one, remember for your table, just use your two numbers in your inequality, 0 and 5. Plug in your 0, you get out a negative 3. If you plug in a 5, you get out a 7. Now in this case, this inequality is not equal to, so this is an open point. But this inequality is equal to, so this is a closed point. So it starts at an open point of 0, negative 3, ends at a closed point of 5, 7. 4, 5, 6, 7. Oops. And then on this middle part, it just starts at the first point and goes to the second point. It doesn't continue in either direction. Does this pass the vertical line test? Is it a function? It sure is. At the x value of -2, we can see the output is -1. At the x value of 0, again, the output is -1. And at the x value of 5, 1, 2, 3, 4, 5, the output would be up here, and that was at 7. And you could have done that with the equations as well. I just like to use the graph when I can so I don't have to calculate those. And that's your homework for Target 12.